Hello my dear students, my name is Rahul. I'm a postgraduate in engineering from Chalak University, Kolkata, and I'm the founder of Learn with ER classes in mathematics. So dear students, this is my new YouTube channel and I will be posting videos every day now in mathematics, and my classes is ranging from classes 7th to 12th, including the engineering mathematics of colleges in different streams and different degrees. So this is the content which I'm going to provide, and I promise you that I will be providing very interesting content in mathematics. And in order to get engaged to my channel, which I definitely want so that I can get motivated to make videos more and more, and in order to do that you need to subscribe my channel. So please take a little time of yours and subscribe my channel, and also to hit the bell icon alongside that so that you can never miss a new video that I will be posting. So let's get started with today's video. It will be volume integral part 6 of vector calculus, but I will also tell you guys that before you visit this particular video, please go through the other parts, also part 1 to 5, so that you can get all the conceptions necessary in vector calculus, and then visit this particular video also. So I will see you again, and yes, keep watching, and let us go to the video now. So here we are on the vector calculus volume integral part 6, and we are going to get started with volume integral today. So the first thing that we need to know is the concept of volume integrals. So if V is a region in space bounded by a closed surface S, then volume integral of the vector point function f is triple integral V f vector dot dv. Now in the previous lectures on surface integral and line integral, we have told you that if it is a line integral, it has to go over the line. Okay, it is not going inside the surface, only in the line. After that, on the surface integral, we talked about going on the surface. Now if it is a surface integral, it will go on the surface. The integration will be made on the surface. Now it's the case of volume integral. Now if it is a case of volume integral, then of course you can understand it will be going throughout the volume of the surface. Okay, so that is the difference between the three integrals. Now in line integral, we use only one integration symbol. In surface integral, we use two, meaning that surface consists of two dimensions. One is the x, one is the y. And now in volume integral, of course, we are going to use three dimensions, x, y, and z. So we are going to talk about triple integrals. So this is the basic concept of volume integral, and this is the representation, triple integral v f vector dot d vector. Now let us go to the next one, that is the evaluation of volume integral. Now in order to do volume integral, we need to you might need to perform the component form of the volume integral, and for that let us take f to be f1 i cap, f2 j cap, and f3 k cap. Then the volume integral, the triple integral v f dot dv, that will be equals to I cap triple integral f1 dx dy dz plus j cap triple integral f2 dx dy dz plus k cap triple integral f3 dx dy dz. So this is the representation of the volume integral in the component form. Okay. Next, let us go to a question now. So this question will explain all the information that is important for the volume integral. Okay. Let us go through the question first. Evaluate triple integral nabla cross f dv. Now nabla cross f dv means they are evaluating the curl of the vector f. Okay, where f vector is given to you 2x square minus 3z I cap minus 2xy j cap minus 4x k cap, and v is closed region bounded by the planes x equals to 0, y equals to 0, and 2x plus 2y plus z equals to 4. So these are the three planes with which this particular thing is bounded, and we have to evaluate the triple integral nabla cross f dv. So this is our question. Now, the first step that we need to do is to find the curl of the vector f, because our question says so. We have to evaluate nabla cross f. In order to evaluate this one, in order to find the vector volume integral of this one, we need to first of all find the curl of this one. So the process is very simple. If you have not understood how to find out the curl, I will tell you to visit the previous videos, and this will help you to understand how to find out curl. So nabla cross f, simply we will put the things, the different values over in the determinant, and then we are going to perform the determinants. And finally the result that is coming to us is j cap minus 2y k cap. So this is the first step, that is to find out the curl of the vector f. This is step number 1. Now the next step is to find out the path of integration. In the line integral, in the surface integral, I have mentioned that you need to mention the path of integration, unless you won't be able to integrate the particular question that is given to you, the different whatever is coming to you. In order to integrate that, you need to find out the path of integration. Path of integration, that means the limits of the different dimensions, the limit of x, the limit of y, the limit of z. Here, since this is a volume integral, so we need to put all the 3 dimensions on the line. We need to put the x, we need to find the limit of x, we need to put the y, we need to find the limit of y, we need to put the z, we need to find the limit of z. Now in this particular diagram, as you can see, if I compare this with the previous diagram that we have, now see, you can understand this is the diagram which is in the xy plane. Okay, so this is A, this is B, and that is the point which is the origin, and they have taken it in 2D, so they have not mentioned the z-axis in the coordinate also. So yes, so this is A and this is B, and they have mentioned the strip as p dash q dash. The reason is because they have already mentioned a strip for the volume integral on a 3D basis, that was pq, so it's a part of that particular strip only, so they have mentioned it as p dash q dash. And the equation of the line, you can find it from the coordinates given to you also, so that will be x plus y equals 2, and we have A equals to 2 comma 0 and B equals to 0 comma 2. Now clearly we can see here, just like we have performed in the surface integral, how to find the limits. So x goes like 0 to 2 and y will change from 0 to 2 minus x. That means in this particular section we need to put y on one side, maybe let's say LHS, and we'll take everything else on the other side. So y will be equals to 2 minus x, that is the other limit, and here of course y is 0 because we are landing on the x-axis. So this is how we are going to talk about the limits of x and y. That is the first step, to find out the path of integration. Now the next step, in order to find out the limit of the z, because now we are doing volume integral. When we are doing volume integral, we need to understand that it is not only about x and y, this is also about the z also. So what will be the limit of z? So for that we need to go back to the previous diagram that we started with. So yes, you can see this particular strip over here, this is pq, and from here to here we need to talk about. So here we can get the equation here. This is 2x plus 2y plus z equals to 4. This is the equation. From here we can take z on one side and put everything on the other side. So z will be equals to 4 minus 2x minus 2y, and that will be the top limit. And what will be the bottom limit? If the bottom limit starts with p, so automatically p is lying on the xy plane, and there is no component of z in the xy plane, so obviously z will be 0 at p, and at q z will be on the particular diagram that we have drawn over here. So at q z will be equals to 4 minus 2x minus 2y. So this is how we are getting the limit of z as well. So according to the elementary volume, that is the bigger one, pq, z varies from 0 to 4 minus 2x minus 2y. So this is the limit of z. So we have got all the 3 dimensions and the limits. Now we can perform the work done. That is our next step. So here, step number 3, this is work done. So in order to perform the work done, we need to provide the limits of all the 3 integrals. We will start off with the x, then y, then z. Now see, you can change it according to your wish, but this is something which I will recommend you to do so that you will have less chances of doing any kind of error. Okay, so similarly we will just put all the different values. The first value will be for z, as we have put it on the third integration. So this will be covered first, followed by this, and then followed by this. The first integral will be the last to be performed, and the third integral will be the first to be performed. So that is the rule of this particular volume integral. Okay, so now in this case, as we can see, there is no z component over here, so only the z will stay because we are going to integrate dz. Now after integrating dz, we are going to put the limit. When we have put the limit, then we are going to multiply this particular thing with here. Now see, if you put the limit over here, you can get 4 minus 2x minus 2y minus 0, that means nothing. So this 4 minus 2x minus 2y is going to be multiplied with z as well as 2y. So as you can see here, 4 minus 2x minus 2y multiplied with z, Then 4 minus 2x multiplied with 2y, again 2y multiplied with 2y, that becomes 4y squared. So they have done it like we have performed it in different versions, right? We have not performed it totally because we wanted to make sure that we are getting the results simultaneously properly. Okay, so you can do one more step. You can just put it together, then again segregate it. That's a different thing, but we have put it on one particular step. Okay, the next one, finding the work done. So what we were doing is we have now put, now if we go to the previous one, as you can see, so here we have put all the values. Now what we are doing, we are providing the integration with respect to y, that is the second integration. Okay, the first was z, then the second is y. So wherever there is y, it is going to be integrated. Wherever there is x, it is going to be constant. So this is all about the next step. So as you can see here, this is y, so it is getting integrated. Again there is a y square, y cube by 3. So just you need to continue with the previous lines, whatever you have gone, you have to just understand where we are getting the integration done. So here you can see integration of 2y is giving you y square, so automatically we have put the limits. Again integration here also we are getting, and here it will be y cube by 3 because here it is y square to be integrated, here again y square. So like this we have integrated all the different things. Okay, now we are going to put the limits again. So here y, if you put the limit, it will be 2 minus x, and here 4 minus 2x, we have made it 2 into 2 minus x, again the same thing only. So the reason why we are doing so, because we wanted to make sure we are getting a 2 minus x whole square as a common. So if you make it as a common, you are getting 2 times 2 minus x whole square minus 2 minus x whole square, that will be only 1 time 2 minus x whole square. And here we also took the same thing, 2 minus x whole square, and here it is 2 minus x whole cube. So here 2 minus x into 2 minus x whole square is also giving you 2 minus x whole cube. So 2 minus 4 upon 3, that will be giving you 2 by 3 whole square. Yeah, 2 by 3. Okay, so let us go to the last slide. Here we are going to end the particular finding the work thing. So here what we have done, we have taken all of these things as common. So here it is 2 minus x whole square, and here it is 2 by 3 2 minus x whole cube something. So yes, 2 minus x whole square of z cap minus 2 by 3 2 minus x whole cube of k cap. So now what we are going to do, we are going to put the final integration, that is for the x. So here as you can see, this is 2 minus x whole square, that will be cube by minus 3 since there is a negative sign. So this is minus 3, again 2 minus x whole cube, so it will be 4 and minus 4, and this minus and minus will be plus. So like this, if you put the values 2 and 0, you will end up getting this particular result. So this is how we are performing the volume integral. The technique is very simple, the process is also very easy. Only the thing that you have to understand, the basic, the most important part of the volume integral is the path of integration, because you need to know which particular limits you have to put in order to find out the answer. If there is a jumble with the limit, then you can rest assured that your answer is absolutely not going to come. So it's very important for you to go through the path of integration. You understand where to integrate from. Okay, so this is something we have to work out, and I hope from this particular question it is pretty much clear to you how we are actually finding out the path of integration. If you have any kind of issues with that, don't forget to drop a comment, and I will make sure that I will make another video if requested on this particular issue of how to find out the path of integration, something like this. Okay, so anyways, that is the end of today's video. I hope you have understood the question, you have got the idea how we are performing volume integral. So this is the end of today's video, and the next video will be coming on a different topic in vector calculus, and we are going like every day I'm making a video. So I hope you guys will be connected to me, and please subscribe my channel if you are new to my channel, so that you are getting all the updates of my new uploaded videos. So until then, take care, and I will see you again on a new video. Bye.